can affect either intracranial pressure or intraretinal pressure. The second thing that we'll be doing is really looking at the brain circulation and how that affects blood pressure within the skull. And there are, as part of the circulation, there are three aspects of fluid moving in and out of the brain that could affect this. One are the arteries and the blood going into the brain or skull cavity, and two, the veins that bring blood and fluid out. And a lesser known vascular system that's in the neck that drains the head and the brain is the lymphatic system. And I have a short video that shows some of the action of the lymphatic vessels that we isolate and study. So this is an isolated lymphatic vessel. And when you think about the pumping that occurs in the cardiovascular system, you usually think about the heart. The heart has a rhythmic pumping. It has valves that keep blood or fluid moving in one direction. Well, if you see in this, in the very middle of the picture, you'll see a set of small valves, and those valves keep fluid moving one way toward the heart. And these lymphatic vessels are throughout the body, but it really is the lymphatics in the neck that helps determine the blood pressure, or the fluid pressure, in the brain as well in the eyes. And so we're going to be looking at this. We're working with several other scientists on this interocular and intracranial pressure. Dr. Vivian Mao at Loma Linda University will be studying the eyes with us, and Dr. David Zaveja from Texas A&M University will be looking at the lymphatics, and of course my lab will be studying the arteries and the veins. The other biomedical issue that is being studied with these animals is locomotion. Because microgravity, you have a fairly severe physical inactivity that can affect a number of organ systems, such as muscle and bone loss that you've heard about. Well, we're in this project, it's really Dr. Jeff Willie from Wake Forest College of Medicine, and he'll be looking at how the animals locomote before they go into space, and then once they get back, how their locomotion has changed. And then specifically, he's also going to be looking at the cartilage in the joints, because with severe inactivity, you get degradation of the cartilage in the limb joints, and so he will be studying that in these mice. So really, again, rodent research is geared toward helping us maintain and understand health issues with astronauts, particularly as it relates to long-term space flight and being in space for months to years. So thank you.
Thank you, Dr. Delp. And Dr. Delp will stay, will you? Take a few questions. Do we have any questions in the room? And please do hold up your hand and wait for the microphone.
Thank you. What makes rodents the ideal candidate for this type of research as opposed to other animals?
Well, there are better animals. For example, non-human primates would be probably the ideal. But with rodents, both mice and rats, you can fly larger numbers of the animals. The other thing is that rodents and mice and rats, they have their lifespan is shorter. They have a higher metabolic rate. So changes that occur in weeks in mice and rats take months to do. So 30 days of a mouse being in space is roughly the equivalent of 3 years of a human. So we can really get a very good look at what long duration space flight will be like, particularly as we think about manned missions to Moon and Mars.
I believe we have another question in the room. Please wait for the microphone.
Yeah, Jose Andrade from Engadget.com. Do you expect to have several different generations of mice in there, or is just one generation that you're sending?
Just one. It's 20 mice that we'll be sending. Yeah. They'll be going up at 6 weeks of age. Well, unless there are delays.
Do we have any other questions in the room? Please wait for the microphone.